All right, this is basically the answers to the homework for quantum numbers homework, the one that's due over Thanksgiving break. If you know how to do this, good for you. If you don't, then this will help you because I'm obviously going to give you the answers, but also walk you through how I got the answers. So if you're still confused after this, I've also put up a few other videos of people other than me talking, so maybe someone else teaching you might be more beneficial, but we'll go ahead and get started. So number 1 says write each set of quantum numbers for electrons in 3s orbital. So if you'll remember, hold on. So the 3s orbital, guys, is located, here's 1s, 2s, and then here's the 3s orbital, okay? So we're talking about 2 electrons in the 3s orbital. This is the 3rd energy level, so that's 3, and this is the s block, so that's 3s. So we're talking about 2 electrons in this block. So how I like to do it, so I write it up here what I'm doing, so that's 3s, and I like to write the parentheses for each electron just so I know what I'm dealing with. So one parentheses, I'm just showing you in the parentheses, we're going to write the n quantum number, L, the m sub L, and the m sub S quantum numbers. So that's the order that they go in. I'm sorry, my camera's on this like focusing weird. I don't know. But you get it, okay? If you've paid attention in class, you get what these letters are. So in this particular example, we have 1 electron and 2 electrons that we're going to find. And so for example, the first electron, the configuration is 3s1, and the second configuration is 3s2, just like that. So n will always be, for both of these electrons, the n is going to be 3. Okay, so both of the electrons, n will equal 3. So I'm going to go ahead and put my n value here. Then the next value I need to find is L. So if you'll remember in the notes that you should have written by now, in the PowerPoint, which is right above this video, L tells you that to find L, you're going to look at this, the orbital, okay? And S equals 0, P equals 1, D equals 2, and F equals 3. So since we are dealing with S both times, it's going to equal 0. So I'm going to go ahead and put that value right here. Okay, so both electrons, the first one and the second one in the 3s orbital, will have both of the n and L values equal to each other. All right, so then we have the m sub L and the m sub S. So basically, since L equals 0, the only sublevel we'll have for S is 0. So technically, both of them are going to equal 0. Okay. So now we're just going to put our electrons in, depending on if they're spinning up or down. So they always spin up first. So I'm going to put the plus 1/2 value here. And the next electron, the 3s2 electron, is going to spin down. So I'm going to put minus 1/2. And that's how you would answer the question if I were to ask you to write each set of quantum numbers for the electrons in the 3s orbital. Okay? I have shown you this in class as well, but just for a reminder, or if you were absent, this will help you. Next, we're going to basically do the same thing, but for the 2p orbital. All right? So we're going to have 2p right here. All right, so I'm not going to write this part because you guys, can look back at it, but we're going to have 6 electrons, okay? So because 2p, so 2p, you can't see. Hold on, I have to zoom out. Okay, yes, I know this is ghetto, but 2p, so this is 1, 2, and then P is right here. So the 2P is right here. So we're dealing with 1, 2, 3, 4, 5, 6 electrons in the 2p orbital. So I'm going to write my 6 parentheses before I get confused. So we're going to do 1, 2, 3, 4, 5, 6. Okay. You don't have to do that. This is just my preference on how I like to solve these. So I'm also, just because, so I can reference some kind of electron number, I'm going to write the electron configuration for just the last electron configuration of this, which is 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Okay, so I've wrote those. So now I have some kind of representation for each electron in the p orbital. Okay, so for all of these guys, n equals the same thing, right? N equals 2, because 2 right here. So n equals 2. So I can also look at this. That's the n. So they will all have 2 for their first quantum number. 2 and 2. Okay, so the L, we are now on the L quantum number. Okay, and remember L has to do with this thing. So if it's a p orbital, if you'll notice in your notes, remember S equals 0, P equals 1, D equals 2, F equals 3. So P in this case equals 1. Okay. So L equals 1 on all of them, right? Because these all have p orbitals. Why aren't you focusing? Okay. So 1, 1, 1, 1, 1, and 1. Okay. Okay, so they all have 2s, they all have 1s because they all have 2s and they all have p's. Now, the m sub L and the m sub S, I kind of like to do together. So the m sub L, okay, so if you'll look at the m sub L, it's it's the range of L minus, or the negative L to the positive L. So to write it out, it would be negative 1. Since L equals 1, it'd be negative 1, 0, positive 1. Okay, so kind of think of, oops, that's a little high. Think of these as those circles that we did in the orbital notation, okay? So the third number is either going to be negative 1, 0, or positive 1, depending on how many electrons. And we just kind of basically fill in the electrons like we'd fill in the orbital notation circles, and then we fill out our answers. So with 1 electron, the first electron in the 2p orbital, we go ahead and fill it out like we're doing our orbital notation. So it's in the negative 1 spot, spinning upwards, which is a positive 1/2. So we go over here and we'll write negative 1, and it's spinning up, so it's a plus 1/2. Okay. Next, the next electron is spinning up as well. Remember the rules, we do 1 in each sublevel before we do the second one, and they point up first before they start pointing down. Okay, so then the second electron we just filled out was right here. It's pointing up and in the 0 sublevel. So we have 0 and it's pointing up. Okay, so now we fill out our third electron, just right here. We fill out our third electron, which is the arrow's pointing up, and then the arrow is located in the plus 1 sublevel, and it's pointed up, so it's a plus 1/2. So it's plus 1, and it is plus 1/2. Okay, we're basically going to do the same thing with the fourth electron. And the fourth electron, remember guys, is going to go pointed down. And that will be located in the negative 1, and it's pointed down, so it'll be negative 1/2. So that one will be negative 1 and negative 1/2. The fifth electron, 1, 2, 3, 4, 5, is in the 0 sublevel, and it's pointed down, so we're going to write 0 and negative 1/2. And the last one, the sixth one, is in the plus 1 sublevel, plus 1, and it's pointed down, so it's a negative 1/2. Aldaxi? Aldaxi. Kala, miss, I get it. Okay. Next, write a configuration for the following. So basically it's wanting like the 1s2, 2s2, 2p6. So automatically we know that the first number is 2. Okay? Because of that. Wow, why is it so not even? Give me a second. I want to see if I can make it Hold on. Okay, children, I think I may, it's still kind of blurry. It may look better, but whatever. Okay, so we know that the first number is 2 because of this. Next, we have 1. So this represents the orbital that we're in. So remember, S equals 0, P equals 1, D equals 2, and F equals 3. So this one equals 1, so it's obviously the P orbital. And now these two, I kind of do together. But that's my preference. Once you guys figure out what we're doing, you may have a better preference or maybe a shortcut that you want to do. So since L equals 1, it's going to be, and remember this is N, L, M sub L, and M sub S. So remember that, what's it doing? Okay, so if you'll remember, guys, that this number is the range of negative L, 0, and positive L. So it's a p orbital, so I just know there's 3. Okay, if you don't know, that's fine. You would just write the numbers -1, 0, and positive 1. So you would then know it was 3, but you should know it's 3. Then we have so it's at 0, okay? So we know that whatever electron we're talking about or element is going to be in this 0 because of this, okay? So I know it's in the 0, and I know that the spin, if you can see, hold on, the spin is a -1/2. So I'm going to fill it in until I get to the -1/2 in the 0 sublevel. So 1, 2, 3, 4, negative spin in the 0. So it's the 5th electron. So since it's the 5th electron that got where I needed to go, the last electron is this. So the actual configuration, so we have 2p5. So the configuration is, we'll do noble gas for fun. Oops, it's not neon. Oh my goodness. So the electron configuration, okay, is we have helium over here. Yeah, helium. So the noble gas will be helium because we're going to, what is it? We're going to, oh my gosh, we're going to 2p5. So with 2p5, we're basically trying to get to fluorine, okay? You can't see it because of the glare, but we're trying to get to fluorine. So we go to helium is our noble gas, and then, can you see? Yeah. So helium, and then it's 2s2 and 2p5. That would be technically the answer, okay? So now we're just going to do the same thing. I know that the first number is the best. Okay, so I know that the first number is 4 because I see it right here. It's 4. This says 2. So I know that remember, this is the orbital, so S equals 0, P equals 1, D equals 2, F equals 3. So in this case, it's D, so it's 4D. And then now I have to use these two numbers to find out what the superscript is, the electrons. So since it's a D orbital, if you just know, you know that it has 1, 2, 3, 4, 5 sublevels. If you didn't know that, that's okay. Look at the L. It's going to be -2 all the way to +2 in whole numbers. So it'll be -2, -1, 0, +1, +2. Okay, so since we are in the 0 sublevel, okay, so it's going to be here, okay, and we're going to go all the way until we have this negative 1/2 spin. So we're going to fill it out in the order we're supposed to, like I showed you in class, and then you fill it out until you get to the negative spin in the 0 sublevel. So I'll go ahead and do it. 1, 2, 3, 4, 5. Remember, you always want to fill it up with each sublevel up with 1 electron before you fill up the second one. 6, 7, 8. So then the superscript is 8. Okay, so it's 48. So then the noble gas configuration, go ahead and lift it up. So the noble gas configuration, so 4D8, so that's the second. It's right here. 4D is this one. Let me zoom out. Okay, I'm zoomed out. So 4D is here. That starts with yttrium. Okay, and then you just 4D8. So you go all the way and count to 8, and that's palladium. Okay, wait, 1, 2, 3, 4, 6, 7, 8. Yeah, that's palladium, the PD. And so you basically go up and you go over to the nearest noble gas. So palladium is here. You go up and over, so you have krypton, okay, so your noble gas will be krypton. Okay, it's kind of hard doing this. I still need an assistant. So noble gas right here, open it up, it's Kr. So krypton, and then the next one will be 1, 2, 3, 4, 5s2. Because we're going to 4,8D, and then 4D8. I said 4,8D, I think. Either way, the ending is 4D8. Okay, so that's the answer to B. Easy, huh? So the next one, I know it's going to start out at 5, so it'll be 5 because of this guy. 3, oh. So remember S is 0, 1 is P, 2 is D, 3 is F. So we have 3, so it's going to be 5F. Okay. And then we use these guys to find out how many electrons I have in the 5F orbital. Okay. So in the F orbital, we know that there's 7. Okay. So we know that there's 7, but we can also look here, and it's going to be -3 all the way to +3. So 1, 2, 3, 4, 5, 6, 7. It's going to be -3, -2, -1, 0, +1, +2, +3. Okay, so that's how you would write that out for the F orbital. Okay. Next, we will fill out the electrons until we get to this guy right here. Okay, so we're basically at the +2, so that's all the way over here. +2. Okay, so the +2, and then we're at the -1/2 spin. So we're going to fill all the positive spins, and then we do the negative spins, and till we get to there. Basically, it's the second to the last. It's the literally the next to the last electron. So I'm going to just do it real quick because you guys should know this by now. If you don't, you should totally review the videos above because you're kind of behind. Okay, I know there's a lot of kids absent, so. And the -1/2 and the second one is this one. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 electrons. So I'm going to put that here. 5F13. Okay, so now we just do the electron configuration for it. So 5F13, this is where noble gas configurations really come in handy because we don't want to be writing all of these. So 5F is literally this. Okay, let me zoom out. So this is the 5F orbital, or 5F. Okay, and then we have, so we go here, so technically it's here, all right? So it's somewhere here. So we go up a level and to our nearest noble gas, which happens to be radon, okay? So we'll do radon is our noble gas configuration, so we don't have to write a ton of things. I'm going to zoom in again because, okay. So the noble gas configuration for 5F13, first we do radon. So, I'm sorry, it's hard to look around this camera. I'm not the best. I need one of those things with the little stands. All right, so Rn, and then we move on to 7, which is the very bottom S, okay? I'm not going to zoom out because it takes too long. 7S2. And then we go to 5F13. Okay, so that would be the electron configuration for this quantum set of quantum numbers. All right, so now it says write the configuration for the electron. So we're basically doing this again. Okay, actually I think we can skip this one, okay, because it's basically what we just did the previous 3. There we go. Or maybe I can just hurry up and do it. So this would be 4. 2 is equal to D. And then we have, so D would be 1, 2, 3, 4, 5. So minus 2, minus 1, 0, plus 1, plus 2. And then we fill it up until we get to the minus 1 spinning up. So it's 1, 2. So it's 42. So then 42, 42, that's zirconium. So then the nearest noble gas is krypton again. So then we would write krypton. And then it would be 5s2, 4d2. So that would be the answer. Okay. Next, the electron paired with that. So first I'm going to do just what it is, okay? So first it's plus this one. So it's actually, if it's paired with it, it's going to be the minus version. So minus 1/2, okay? So minus 1/2, so just kind of assume it's everything's the same, just minus 1/2. So you have 3, and if it's 1, so 1, that's a p orbital. So 3p, so we're going to fill it up. So p has 1, 2, 3, and that 1 will mean that we have -1, 0, +1. And then we have, so it's going to be here, and we're looking for electron paired with this, so it's really going to be the minus 1/2, so it's going to be 1, 2, 3, 4, 5th electron. So it's going to be 3p5. So then the electron configuration, we're going to do the noble gas Ne. You guys should know electron configuration. Again, if you don't, then you should probably review. So that's 3s2 and 3p5. Just like that, okay? Noble gas abbreviation for these. So again, same thing, guys. I already told you, we've gone over these. So this one, it says atom with 5 electrons in the 3rd energy level. So 3rd energy level, so this one we have to actually look at the periodic table. So the 3rd energy level, there's 1, so this is, sorry, 1, 2, 3rd energy level. So the 5th electron in the 3rd energy level, remember, goes SPDF, so S, so this 1, so this is the 3rd energy level, 1, 2, 3. So it's 3, this is 1 electron, 2 electron. Go over here, 3 electrons, 4 electrons, 5. So we're talking about phosphorus. So basically what this question is asking, the atom with 5 electrons in the 3rd energy level, is atom with 5 electrons in the 3rd. So it's phosphorus. Okay, and it's going to ask for the, and it's asking for the noble gas abbreviation. So you would literally just find phosphorus on the periodic table, go up and over. That's neon is the first, the neon is noble gas. So it's Ne, and then 3s2, and 3p. And phosphorus is the 3rd one. So that's it. So you guys should know noble gas configurations. I'm not going to show you. Again, you're going to identify it by going through that. Name the element described. So 4F3. So 4F3, you would just look over here. So remember, this is 4F, and that's 1, 2, 3. So that would be, hold on. So that would be PR. Okay, so for F3 would literally just be PR. Okay? That's more of a review from what we've done. And then you're going to name the element described. So you're going to just do this. So that's 3. 2 is D. Okay. And then you have 1, 2, 3, 4, 5. And it's -2, -1, 0, 1, 2. And then it's in the 2nd with the -1/2. So it's going to be, whoops. So it's going to be here. It's basically the very last one, isn't it? So up, 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 down, down, down. So it's that one, the -1/2. So it's 3D 10. Okay. So 3D 10, and it's wanting you to name the element. So 3D 10, if you will, bear with me while I zoom out. So 3D 10, this is 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, zinc. Okay, so that one happens to be zinc. All right, guys. So all of that's self-explanatory. This one might be confusing simply because it's not in the correct order that you're used to be giving these numbers. So n equals 4, so technically that's the first one. L is equal to 2. So remember, when L equals 2, it's on the d orbital. And then you're going to use this number and this number to find the electrons. So if it's D, 1, 2, 3, 4, 5. And where's L? It's 2. So it's -2, -1, 0, 1, and 2. And then, so you're going, so M sub L is 2. So you're going to go all the way to here. And it's going to be a plus spin. So 1, 2, 3, 4, 5. Okay, so it's basically 45. So whatever element is 45 is your answer. So 45 happens to be, so this is, sorry, this is 3D. This is 4D, so 41, 2, 3, 4, 5. And that is technetium, whatever. So it's a TC, okay? TC. There we go. So all of that's easy. Next one we're going to do the question, explain briefly why each set of the following is not a possible set. So this one is very, check your understanding very well. So basically what it's asking is, why can't this happen? So obviously these are all three going to be impossible, but now it wants us to tell them why. So this one, n equals 2, so it would be 2. L is equal to 2, so it would technically be in the, sorry, let it focus. Okay, so it would technically be in the d orbital. So do you see the problem here? If you look on the periodic table, guys, what energy level does D start at? Does it start at 2? Is there a d orbital in the second energy level? So already we know this is bad because this is not a thing. So it says briefly explain why. So I would say basically there is no d orbital in the second energy level. So there is no, come in, d orbital. Hi. And thank you, ma'am. The second sublevel. Bye. Okay, so that's what I would write. I didn't even have to check the other ones. I knew for sure that one was wrong. Okay, let's look at the next one. N equals 2, so 2, no big deal. L is 1, so P, no big deal. I'm okay with that. So P can be one of 3, so it's -1, 0, +1. So M sub L, I'm okay with that because it could possibly be this one. And oh my gosh, what is this? Okay, so there's my problem right here. There, M sub S is, it has to be either a +1/2 or a -1/2, okay? So that's where they went wrong. So I would write something like M sub S must be either, I know it's blurry, sorry, +1/2, yeah, or -1/2. Okay, there is no 0, there is no 1, it's a plus or -1/2. That's why I like MS, because it's really easy. Let's look at this guy. So N equals 3. Sorry, I cut my thumbnail cutting strawberries. Okay, so N equals 3. I'm okay with that. L equals 1, so it must be a 3s. That's possible. Oh, yeah. 1 is actually P. I'm still okay with that. There is a 3P. Oh, yeah, I don't like this. So technically P has 3, right? 2, 3. And it ranges from -L to +L. So -1, 0, +1. And I don't see +2 anywhere on that. So here's my problem right here. Okay, so in this particular case, M sub L value sorry, my camera got hot because I talked too long. My bad. I don't even remember what I was saying. Okay, oh yeah, okay, so that can't be that. Okay, so the M sub L value can't, or I'm sorry, the M sub L value must be in the range of -L, that's an L, -L to +L, okay? So I would have accepted any of these 3 for M sub L, but it's not, and so I don't like it. Now, this is saying what is the maximum number of electrons that can be identified with each of the following sets of quantum numbers. In some cases, an answer may be none. All right, so N equals 3. So this one, I'm going to kind of take out. I'm sorry. Whoa. I'm not the best, like, video lecturer. This is why I don't have a video lecture YouTube. Okay, so basically the last part I'm going to show you is what is the maximum number of electrons. I already read that. So when N equals 3, so that's basically the whole third sublevel. So that's 1, 2, so this is the third sublevel. I'm sorry, not sublevel, energy level. So this is a third energy level. All of this is a third energy level, and all of this is third energy level. So basically 2 plus 10, which is 12, plus 6, which should be 18. So the maximum number of electrons that we can identify for this one is 18. 18 electrons. So 18 electrons. Okay, so if N equals 3, okay, and L equals 2, so we're on our third energy level again, but L equals 2. So this is 1, that's, 0, S sublevel, 1 is P sublevel, and D is the second sublevel. So basically we can only identify N equals 3, which is the third sublevel, and 2, so that's the D. So that's basically 10 electrons we can identify. So, sorry if I'm making you sick. 10 electrons, up to 10 electrons that we can identify. So now we're looking at N equals 4. Okay, so that's the fourth energy level. So that's 1, 2, 3, 4. So that's here, 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 and don't forget about the F, all of these guys. So technically, oh, it got very specific. It's very specific, so it's only 1. Once we got down to here, once we're doing the spin, guys, it's specific enough that you can only identify 1. So cool, I didn't have to think that hard. 1 electron, okay? Next, if we'll look here, N equals 5. So N equals 5, so that's, whoa, 1, 2, 3, 4, 5, okay? What does L equal? 0, so that's got to be in the S orbital, so that's 0, so it's just these two. So far we're down to 2. And now we're looking at M sub L equals 1 plus 1. Okay, I already don't like that because this guy, remember, M sub L has to be in the range of minus to plus L. Minus to plus L is still just 0 in this case. So I'm going to write none. Wow, that looks like a kid's handwriting. None. Okay? So I've kind of explained a few examples of each one. I'm pretty sure with understanding and review, you guys are going to do great on the test. So if you have any questions, bring them to class and we will discuss them while we do our review in the test. And I believe that I'm going to go over some of the review with you in class and kind of do it this style if you like it. I don't know if you like it. So we'll talk about that in class too. Bye.